Okay, good afternoon. We are going to go through section 6 notes. So I want to make sure that you are turned to page 195 in your student journal. I want you to write down the notes that I go through with you. And then you will work on your homework and check your answers. Okay, so first of all, I want to go through what a sequence is. Okay. So a sequence is a list of numbers that follow a pattern. Okay. Now, there are two types of sequences that we need you to be able to pick out. Okay. One is called an arithmetic sequence. The other is called a geometric sequence. And today's big focus is going to be about the geometric sequence, and you'll see here why in a little bit. So an arithmetic sequence is a list of numbers with a common difference. Okay, well, what does that mean? Okay, a common difference just pretty much means we are going to add or subtract the same number to each term. So, for example, 2, 4, 6, 8, 10, 12. This is an arithmetic sequence where the common difference is 2. Okay, why do we call it a common difference? Because if we subtract terms from each other, like if we subtract the first and second term, second and third terms, third and fourth terms, every time we're going to get the same difference. Okay, so write down what you think is another example of an arithmetic sequence. Okay, here's one that I'll write down. 10, 6, 2, -2, -6. Okay, what's happening here? I am subtracting 4 from term to term. Okay. Now, our big focus is going to be a geometric sequence. Okay, so a geometric sequence is a list of numbers with a common ratio. Okay, so what does that mean? If we have a common ratio in our sequence, then that means we are either multiplying or dividing the same number over and over. Okay, so for example, okay, here is an example of a geometric sequence, okay, where our common ratio is 2. We're multiplying by 2. We're multiplying by 2. We're multiplying by 2. Okay, why do we call it a common ratio? Okay, if we take two terms, so two numbers in our sequence, and we divide them, we're going to get the same ratio no matter which two successive terms we grab. Okay, so down here, here's another example of a geometric sequence where we start at 1, we multiply by 5, we multiply by 5, we multiply by 5. Now, we don't have to just always multiply by an integer. Let's say we had a sequence that was 100, 50, 25, 12.5. Okay, what's happening here? We are multiplying by 1/2. Okay, now you can think of this as divide by 2, divide by 2, divide by 2. Okay, and that's totally fine, but our common ratio is actually what we would say is 1/2. Okay, our common ratio is 1/2. That's how we get from one term to the next. Okay, so how about I'm going to give you a moment to write an example of your own. And I want you to share it with your elbow partner and make sure that you agree that both of you have a geometric sequence. Okay, so let's go to the next page. Something that you're going to have to do in your homework is determine if we have arithmetic, geometric, or neither. So let's just make a note. If we have an arithmetic sequence, that means we are adding or subtracting the same number over and over. If we have a geometric sequence, that means we're multiplying or dividing the same number over and over and over. Okay, so let's look at number 1. Okay, what does it look like is happening here? To me, it looks like we are multiplying by -4, multiplying by -4, multiplying by -4. So I notice that we go from positive, negative, positive, negative. Okay, that's interesting. Well, since our common ratio is a negative number, we're going to get that flip-flop. So it looks like we are multiplying by the same number over and over and over. So we are going to have a geometric sequence because we have a common ratio of -4. Okay. Well, now let's look at number 2. What do we notice about number 2? I notice that if we add 4, add 4, add 4, we get to the next term. 3 plus 4 is 7. 7 plus 4 is 11. 11 plus 4 is 15. So since we are adding the same number over and over, this is an arithmetic sequence because we have what we call a common difference of 4. So we are looking for, are we adding the same number over and over or subtracting? Are we multiplying or dividing the same number over and over? Okay, so in number 3, okay, what I notice is that 2 times 2 is 4. 4 times 2 is 8. Oh, well, what happened here? This is 8 times 4 is 32. So since we are not multiplying by the same number over and over, we have a nice little pattern going here, but the pattern is broken. So this is not a special sequence. okay? We're going to say it's neither, okay? There's no pattern, okay? All right, so what I'd like you to do is I would like you to try to do number 4, number 5, and number 6. I'm going to give you a couple minutes to see what you can do here, and then we'll go through them together. Okay, if you're not done, then press pause. We're going to go ahead and look at these. Okay, well, what do you think? Ooh, it looks like we subtract 3, subtract 2, subtract 2. It does not look like there is a pattern. So this is not geometric or arithmetic. Ooh, now in number 5, it looks like we are multiplying by 3, multiplying by 3, multiplying by 3. So this is a geometric sequence where what we call our common ratio is 3. Okay. Now over here, it looks like we are adding 8, adding 8, adding 8. So this is an arithmetic sequence because we are adding the same number over and over. We call that our common difference is 8. Okay, now my biggest thing is you just being able to say arithmetic or geometric or neither. Okay, now I also want you to be able to give me the next terms in a sequence. So I'm telling you that these are geometric sequences. So you need to figure out, number 1, what is that number we're multiplying by each time? And so then we're going to write the next 3 terms in the sequence. Okay, so let's figure this out. We know it's geometric, so we know we're multiplying by a number. Okay, well, what is that number? From 7 to 21, we're multiplying by 3. 21 to 63, we're multiplying by 3. 63 to 189, we're multiplying by 3. Okay, so if I want to get my next 3 terms, we're going to have to continue that pattern. So my next term, we're going to have to multiply by 3. Okay, that would be 567. Our next term, we're going to have to multiply by 3. So I take that number and I multiply by 3 to get 1,701. Okay, and then we have to do it one more time. Multiply by 3 to get our next term of 5,103. Okay. All right, so this is what I noticed about this next one. I noticed that we're decreasing. Well, if we're multiplying by the same number and our numbers are getting smaller, then what's really happening? Okay, you can think of it as we're dividing by the same number over and over, or we're multiplying by a fraction less than 1. Okay, so to me, it looks like we are dividing by 2, dividing by 2, dividing by 2, which is the same thing as multiplying by 1/2. Okay, I'm really pretty flexible about how you want to look at it. Okay, so if we take 72 and we do that same thing, divide by 2, we're going to get 36. Well, if we do that again, we'll get 18. And if we do that one more time, we're going to get 9. Okay. All right, how about you try this one without me, and then we'll go over it together. I'll give you about a minute to see if you can get the next 3 terms, and then we'll go over it together. All right, so it looks like we are multiplying by -2 from term to term. So if we multiply by -2, we would get 80, -160, and then positive 320. Okay, so let's talk about this one right here. Number 10. So it is a geometric sequence. Okay, let's write the next 3 terms. Okay, what's happening from term to term? It looks like we continue to divide by 2. Okay, so notice how we have divided by 2. I'm going to go ahead and say multiply by 1/2. I think that's going to help us here. Because when we get to 3 halves, when we multiply by 1/2, we would get 3/4. And then when we multiply that by 1/2, we would get 3/8. And then when we multiply that by 1/2, we would get 3/16. Okay, 3 halves times 1/2 would give us the 3/4. 3/4 times 1/2 would give us the 3/8. Okay, now when it asks you to graph these, okay, this is what it is asking you to do. So let's say 2, 4, 6, 8, 10, 12. So our first term is 12. Our second term is 6. Our third term is 3. Our fourth term is 3 halves. Our fifth term, okay, do you see how this is happening here? Okay, so what they want you to do is this is the number of what term they are. 1, 2, 3, 4, 5, 6, 7. Okay, and then over here, this is, whoops, this is the actual number in the sequence. Okay, so see what you can do with that. Like I said, my biggest concern are these 2 things. Can you tell it's geometric? And can you find the next 3 terms? If the graphing's a little funky, it's okay. Just give it your best shot. But I'm more concerned about, can you get the next 3 terms of the sequence? Okay, so this is what I need you to do. I need you to work on your homework for the rest of the period. Check your answers. If you get done early, then you will use the remaining time to work on Map Accelerator.